What you just witnessed wasn't an explosion, wasn't light, wasn't sound. So what was it? How can two invisible objects shake the entire universe? How can we hear something that emits no light? And most terrifying of all, what was left behind? On July 12, 2025, three of the most advanced observatories on Earth, LIGO in the US, Virgo in Italy, and KAGRA in Japan, detected something extraordinary. A gravitational wave signal, so strong it could only come from the collision of two enormous black holes. But this wasn't just another cosmic event. This was the most massive black hole merger ever recorded, and it might change everything we thought we knew about our universe. The signal lasted just half a second, but what it revealed was staggering. The colliding objects were black holes, each tens of times more massive than our sun. One of them, an estimated 85 solar masses, the other, 66. Together, they merged into a single black hole with a final mass of 142 suns. That's more mass than some entire star clusters, crushed into a point of infinite density. For reference, the black hole at the center of our galaxy is about 4 million solar masses, but it grew slowly over billions of years. This one, it formed in under a second, which raises a terrifying question. How many more monsters like this are out there, forming in silence, undetected in the deep dark? Now, imagine this not as data on a screen, but as reality. Two invisible giants circling each other for millions of years, bound by gravity, spinning faster, closer, until in a final moment of silence, they merge. No light, no fire, just a ripple, a wave that doesn't move through space, but of space. In less than a second, the two become one. A monstrous black hole is born, and for a brief moment it releases more energy than all the stars in the observable universe. But there's no explosion to see, no debris, no echo, only distortion. A pulse stretching space itself outward through galaxies, unnoticed by every eye, except three: LIGO, Virgo, KAGRA. These three observatories captured it all, and when scientists calculated what had collided, they stopped. It wasn't normal. The final object was too heavy to be a stellar black hole, but too small to be a supermassive one. For decades, we've theorized about an in-between, a missing link in black hole evolution. And now, we might have just heard its birth. Favorite change: gravitational waves. Predicted by Einstein over a century ago, but never directly observed until 2015. These waves don't travel through space, they are space, stretching it, compressing it. And we, humans, have built machines sensitive enough to detect these ripples from over 1 billion light years away. LIGO, Virgo, and KAGRA act like giant ears, listening not for sound, but for the shifting fabric of reality. When two black holes collide, they send a gravitational shock wave rippling outward. And when that wave reaches Earth, it stretches and squeezes space itself by less than the width of a proton. Yet our detectors catch it. This is what makes the July 2025 detection so extraordinary. The wave wasn't just strong, it was different. It hinted at a black hole in the so-called mass gap, an object that shouldn't exist according to our models. A mystery that challenges our understanding of stellar evolution, black hole formation, and the very structure of the universe. Now imagine, what if this had happened closer? Not 1 billion light years away, but right here, in our own galaxy. At that distance, it wouldn't just be detectable. It would shake our solar system. Gravitational waves would stretch Earth itself. Buildings would subtly sway. The moon's orbit could shift by micrometers. You wouldn't feel it, you wouldn't hear it. But space, the invisible fabric holding everything together, would ripple beneath your feet. GPS would desync, atomic clocks would tick just slightly off. And if it happened too close, the energy could tear apart the orbits of planets, strip atmospheres, collapse magnetic fields, and we wouldn't even see it coming. No light, no warning, just one final wave. Then silence. Every time we look up at the stars, we see light from the past. But gravitational waves, they're different. They let us feel the cosmos, not just see it. With them, we're no longer blind to the most violent events in the universe. We can now detect collisions in the dark, hear stars die, watch black holes be born without ever seeing them. This is more than astronomy. It's listening to the heartbeat of the universe. And it's only the beginning. More are coming, more waves, more mysteries. And somewhere, out there, a wave is already on its way. You've been watching Dark Space. Leave a like, subscribe, and tap the bell to catch the next ripple in the dark.